This next example, we're finding 2 points on the plane, and can you please put other than the reference point? So I have people that are heading off to be lawyers and try to slip that through. I don't want the reference point is not one of the points I'm looking for. I want you to find 2 points other than that point on the line. So how do you do that? Well, since I'm looking for no specific point, you can pick any of the infinite number of points. All you really have to do is pick scalar values for S and T. I always tell people keep it simple. Okay, so for example, point 1, let S equal 1 and T equals 0. So that means we end up with, whoops, a vector equation that looks like this. X, Y, and Z equals 2, 0, negative 1, plus 0, 2, negative 1, plus 0 times 5, 3, 4. What happens is that second direction vector, its contribution, it's canceled out since it's being multiplied by 0. So our resulting point, that's what we're giving. We're ending up with a point here. So we're back to round brackets, 2, 2, negative 2. So I'm just adding the reference vector, or reference point, to the first direction vector. So there's my first point, point 2. Flip it. Let S equal 0 this time, T equal 1. You can really pick any value in the world, any real number for S and T, and it will be giving an appropriate answer. But like I said, you don't have calculators, so let's not be silly about this. Let's be efficient. So 2, 0, negative 1, plus 0 times 0, 2, negative 1, plus 5, 3, 4. And remember, these scalar values, the values of S and T, they're really telling you from this point, so from the given point, and I'll show a graphical representation. If that's the point in question, 2, 0, negative 1, so there's the point, it's basically telling you how far do I travel along the first direction vector, and how long do I travel along the second direction vector, whichever orientation it is, to get to my new point. X marks the spot. So it's like a road map. So we're just using vector addition here, really, to get to a new location, and it's just this equation spits out a final point for us. So that being said, that second direction vector won't make a contribution because it's being multiplied by 0. So the resulting point would be 7, 3, 3. All right, and that's all there is to finding any points on the line. So if I ask you to find 10 or 15 points, you're just randomly picking S's and T values. Not that I would make you do 15 or 20 points. All right, last example here. Determine the vector equation of a line passing through a point and perpendicular to that plane. So now we're bringing in stuff that we already know. We're actually looking for vector equation of a line. And what are the conditions? It has to pass through this point. And it has to be perpendicular to the plane. So for the visual people out there, here is my plane. Here's the reference point, point P. And my 2 direction vectors are heading off in that direction, so we'll call that D1. Let's say D2 is going in this direction. My new line has to pass through point A, which I'm going to say arbitrarily is up here, and it has to be perpendicular to the plane. So there's the line I'm looking for. I'm looking for the green line. So it has to be perpendicular to the piece of paper or our plane. It has to go through point A. So for the equation of a line, we need to know direction vector and a point. Like I said already, we have the point. How do we find that direction vector? Well, if it's perpendicular, as soon as you hear the word perpendicular, you should have this going through your mind. Cross product. Because we know if we take the cross product of 2 vectors, let's say D1 and D2, the resulting vector will be a vector that's perpendicular to those two vectors. So that's exactly what we want. So what we're going to do in order to find our new direction vector here, so our new direction vector, it's going to equal the cross product of D1 and D2. So like I said, it never really goes away, that cross product. So make sure you know how to do it. I keep repeating myself with regard to that, but you would not believe how many students refuse or don't really believe me that it's necessary to know it. And the result of the mark is pretty predictable. So, writing it twice, 3, 2, negative 5, 3, 2, negative 5, crossing out the first and last. The resulting vector will be negative 5, take away 12, so I have negative 17. 18, take away 5, so 13. And negative 2, take away 3, it's negative 5. So there's my new vector. So the vector equation of my line then, so therefore, my line x, y, z will equal, not quite sure what bracket that is, that's kind of a lost control of it bracket. So point A again was 2, 5, 1. Now, I have to pick a different variable, and this goes toward your communication. I can't use S, I can't use T, so I need to pick a different variable. So let's go K this time, just to mix things up and walk on the wild side first. Change, and there is the resulting vector, which will be perpendicular to that plane. All right. So what I want you to do is I want to take your newfound knowledge and I want you to attempt some of the homework questions. And like I said, I'm giving you the basics with the note. The homework provides multiple or different approach or different types of questions on how to use this stuff. And those questions are beneficial to complete in order to be successful on tests. So if you have any questions, you know where you can find me.